Another very important concept is the concept of perfect reconstruction. So ideally, we want that the output signal of the cascaded analysis and synthesis filter bank to be identical to the input signal, except for a time shift ending. And this is called perfect reconstruction. So the output is equal to the input apart from this delay or a time shift. A filter bank that has this property is called a perfect reconstruction filter bank. Here we see an example of a perfect reconstruction filter bank. So in this case we would use ideal brick wall filters, and brick wall filters, they have magnitude in passband equals to 1 and otherwise it's 0. We need to pay attention to the Nyquist theorem, so we can downsample the subband signals by factor n without loss of information, and with suitable brick wall synthesis filter we can achieve perfect reconstruction where the input is equal, the output is equal to the input. It's also important to point out that we can use the bandpass Nyquist. The bandpass Nyquist, we sample twice the bandwidth of the signal. So our goal is to keep critical downsampling. So the downsampling rate is equal to the number of subbands. There will be no increase in the number of samples. We want to obtain perfect reconstruction, and ideally we want to cancel all aliasing components. So in the bandpass Nyquist, sampling at least twice the bandwidth FB enables the reconstruction of the bandwidth limited signal. So we are dealing with bandwidth limited signal, and now we are sampling with twice of this bandwidth. So if the lower end of the frequency band is multiple integers of the bandwidth, we achieve a perfect reconstruction. So in theory, we apply ideal filter bandpass filters for the original frequency range, and we fish out the original, and when there is no overlap, there will be no aliasing. However, we have a big problem. Ideal bandpass filters, they are not realizable. So let's talk about ideal filters. So ideal filters, they are not realizable. In the time domain, this would mean a convolution of our signal with a sinc function, and a sinc function is infinitely long and not causal, meaning it causes infinite delay. Then we cannot simply use a DFT or FFT to obtain an ideal filter in the frequency domain either, because the DFT also represents a filter bank, but a special type of filter bank. Its equivalent filters are far from being perfect filters, hence we cannot make ideal filters with it, and not good enough filters for our purposes, like audio coding and how the ear listens. So as we will see later. So it's very important not to use your eye looking at waveforms to guess what the ear might be hearing. Those are quite different processes.